So a quadratic function has a leading coefficient of 2 and a 0 at -3 and a coordinate at 1 and 8. So to generalize this, if we have three parts of a quadratic function, we generally configure the function out. So if I were to sketch this graph out, I've got a 0 at -3 and a point at 1 over 8 up. Okay, and the leading coefficient of 2, so it's a positive leading coefficient. It's probably going to be something like that, right? So if I were to kind of sketch that in, maybe something like that is what we would guess. So if we were to set this up, we have a 0, so we could set this up with the factored form, knowing one of the roots and knowing the leading coefficient. So if I write this out, I write this out as a 2 times x plus 3, and then the other 0 is unknown. So we have two parts of that quadratic function. We need that m value, and we can solve for the m value by using the coordinate 8. It's 1 and 8. So plugging in y equals 8, x equals 1, I end up with that expression. There's only one variable to solve for, so I'll go ahead and solve it. So I end up with 2 times 4. We get 8, 1 minus m. Okay, we can solve this equation. We can see that m is equal to 1. M is equal to 0. M is equal to 0. So solving this, we end up with 0 equals -8m. M equals 0. So we know that that value here, that m value is going to be 0, so it's going to cross the x-axis. It's going to look more like this. Okay, so that point is going to be there, so we know that's going to have a graph that looks more like that. Okay, so then I write my final equation, y equals 2x plus 3 times x. So this one here, the function is congruent to -1/2 x squared and has zeros at 0 and 4. Well, congruent means the same shape, and the a value is what determines the shape. Okay, so it's going to be upside down and vertically compressed. So if I were to write this equation, then we're going to use the same compression factor for the congruency, or the same shape, and writing in the zeros, there it is. That's all we need. So for this one here, we have zeros that are rational values or fractional values. So we have 5 over 2 is one of the zeros. Now to come up with the factors from the fractions, it's always going to be back divided by front. Okay, so the reason why is this. So if I have the factor, for example, let's give an example, 2x minus 8. Okay, so just make that -7. If that's one of my factors, we need that to equal to 0. So when I actually solve for that 0 to get the zeros of the function, I get +7 over 2. It's always the opposite sign of back divided by front. So this is my back, that's my front. Okay, so back, front. So my factors then look like this. 2x minus 5. Okay, this one's going to be back divided by front, so this is going to be 5x minus 1. Okay, so then I still need to make sure I count for my a value, and that's what the y-intercept is going to be used for. But just to highlight this, we have our back, okay, and we have the front. The front coefficient is going to be in the denominator. So solving for the a value, I plug in y is equal to -10 when x is 0. So I plug in x is 0. I get this expression. So I get 5a equals negative 10. So in this case, we have the a value is negative, and I can write my equation out now. Having solved for my a value as well, and again, we have to make sure we solve for the a value, right? We use this coordinate to solve for a. So a is equal to negative 2, and then we have our factors, 2x minus 5, 5x minus 1. It's always the back divided by front. Okay, that's going to be the back divided by the front.